phone. What do people need to do? Subscribe. Swipe up. Right?
Can I get
Tell
my phone out? Or
No. No, you can't have your phone out. All right. Hey, let's do our notes quick. So today's gonna be something new, probably something you haven't done before. It is relatively easy once you get the hang of it. So we're talking about converting rational exponents to radical expressions. So first and foremost, fractional exponents are an alternate way to express radicals. So we call them rational exponents, right? But we're dealing with a lot of fractional exponents, which means we have exponents that are fractions.
Whoa.
All right?
That got intense quickly.
So, if x is a real number, and did I go too fast? You guys got that?
Way too fast.
Okay. If x is a real number and m and n are positive, that is the key thing there. M and n need to be positive, which means we need to have a positive exponent. All right, so anytime you have a negative exponent, it's got to become positive before we can do this. What happens is we're going to change it to a radical. That's what we're going to learn to do today. We're going to change fractional exponents to radicals, and tomorrow we're going to do radicals to fractional exponents.
Whoa.
Right? So, if you got one day, you should be able to get both.
Why?
What's going to happen is our power, I think it actually shows down here too.
Ooh.
Our power is in the numerator. So the numerator of our fractional exponent becomes the power of x, or if you write it this way, it becomes the power of the whole thing. Right? I'm going to do it the middle way most often, not the way on the right. But you can do either way. There's the same thing. All right? Our denominator becomes what we call the index, or the root. All right? The index or the root, and that's all explained when these other fill in the blanks you're supposed to be doing. So the denominator becomes the index or the root. I'm going to call it the root 99.9% of the time. But it's also referred to as the index of our radical. All right? So a lot of you have heard of the square root, right?
Yep.
That's the second root. You've heard of the cube root, which would be the third root. Right? But we're going to deal with like fourth roots, fifth roots, sixth roots, all sorts of things like that. And actually, a lot of your calculators are really cool. If you look on it, if you go to math, the fifth one down has an X root button, which means you can put whatever root you want in there and take the fifth root of 64, per se. Anything like that.
I got it.
All right? Yeah, it doesn't give you a very nice number, but yes.
I like the number.
All right, so there is a nice little button in your calculator for that. The numerator, like I said, this is the other fill in the blank. The numerator becomes the power of the value under the radical, or becomes the power of the whole root. So like I said, depending on how you write it, it's going to be either under the radical or it's going to be the whole thing. The big idea though is that the numerator becomes the power, the denominator becomes the root or the index. Okay? I'll just take a second to write that down because it's a lot of writing.
Yeah, it's too much.
Well, suck it up.
I just hit English, so it's too much.
You said English?
Yeah. So did
Good thing
Jared.
that it's kind of like a laid back class. You don't do anything in there. So
Yeah, but if Jared didn't.
that's what now for you. Pay attention.
Me and Cole sit right next to each other.
Whose class do you have?
We had a student teacher, but now we have to stay with him.
Okay. All right. Are we ready to go? Keep going?
Sure.
Okay. Now, there are a couple special cases. However, they're not really special cases. They follow the same exact rules as every other one. They happen to come out to nice radicals. Right? So in our special cases, x to the 1/2 actually becomes square root of x, right? X to the 1/2 would be the denominator is the second root of x to the first. So what happens is it becomes a square root of x. Same thing with anything to the 1/3. X to the 1/3 would become the cube root of x to the first, or the cube root of x. Right? So anytime there's a 1 in the numerator, it becomes whatever root of, let's say, x. Okay, so they're not really special cases. They follow the exact same rules as everything else. They just come out to be nice radicals.
That's pretty nice.
All right? So, I mean, they're not like certain special cases you have to remember, but they do equal x to the 1/2 does equal the square root. X to the 1/3 does equal the cube root. Okay, I think those are 2 blanks for you as well.
Oh, I didn't.
Farther down your paper. Right? Okay. Any questions so far? Hopefully we do some examples that'll help a little bit. We'll understand it. We'll grasp our concept. Okay?
Okay.
Okay, let's do it. So,
It's on the next page.
before we do those examples, I forgot, I gotta talk about this. There's two different forms we're gonna ask you to write it in. We might ask you to write your answer in exponential form. That means we want it to have an exponent. Pretty simple. Or in radical form, which would mean we want it to have a radical. They're pretty self-explanatory. Any rules that we did on the first day with exponents apply with fractional or rational exponents. Same stuff. You multiply two numbers, we still add their exponents. Power to a power, add their multiply their exponents. Negative exponent, flip it to the denominator or to the numerator if it's in the denominator to make it a positive exponent. All the same rules still apply. So, let's try some. Right now it just wants us to express it as a radical. That's it. We don't need to do any simplifying. We just want to express it as a radical. So, 3 to the 1/2. Right? If I'm making that a radical, my root is my denominator. Right? So 2 becomes my root. 3 is underneath the radical, and the power of 1. Now, do you have to put a power of 1 next to 3?
No.
No, right? 3 to the first power is still 3. That's fine. You could also write this as the second root of 3 to the first power, right? Either one of those is okay. I'm going to do the one here 99% of the time. That's the way I do it. Like if you do it the other way, it's still correct and won't get marked wrong. That's just the way that I do it. Now another question. Do I have to put that root 2 in there?
Yes. Wait.
No.
Wait, what?
Here, that is the only one where you do not need to put that root in there. Because if I just write this, what do you know that as? The square root. It's the same thing as the second root. So if there is no number there, that means it's the second root or the square root. It is the only one where you do not need to put that number in there. Okay? Every other one, the third root, the fourth root, the fifth root, you must have that number in there. But also if you're doing a problem later on in this unit, and you see one like that, you can assume that it is the square root or the second root. Alright? Okay. 7 to the 3/4. Well, I want to write it as a radical. My denominator is my root, so it's going to be the fourth root. 7's my base down here, and it's the third power. Okay? You could also write it as the fourth root of 7 and all that cubed.
That's pretty cool.
Okay? Either way works. Either way is correct. Either way you'll get the same answer. Alright, I need to readjust this quick. I apologize.
Should I stop?
This is the fourth time I've done this in 2
Should I
hours.
stop
I guess
recording?
it's not worth it.
Yeah, well, thanks Jared. I didn't figure that out. Alright. X to the negative 3/2. How am I going to do that one? What's the first thing I have to do?
Put the X inside.
What?
X to the negative 3/2.
Oh, you guys switch it.
We need to make it a positive exponent first, right? Remember, to make it a positive exponent, 1 over x to the positive 3/2, right? We put it in the denominator because it's technically over 1 right now. So we flip it to the denominator and make it a positive exponent. Which means my answer then is going to be 1 over my denominator for my exponent is my root, so the second root of x cubed. Right? Or you can write the second root of x and then all in parentheses cubed. Okay, but it does need to be 1 over, so we need to make that exponent positive first. Does that make sense?
Yeah.
Do we all understand what we're doing? Okay.
Yeah.
Y to the 5/3. What's my root going to be? 3. And that's going to be y to the 5th. Or third root of y all to the 5th power. I will not always write both answers out for you guys. I'm going to do the top way 99% of the time, like I said. If you write the bottom way, do it that way. It's fine.
That's too much work.
Okay? Alright. What about this one? It's a little trickier. 3w to the 1/8. What do you think? Anyone have an idea? Any guess?
3W.
That 1/8, that's an exponent for what? W. Does that have any bearing on the 3?
No.
No. So when I go to make this a radical, it's going to be 3 times and then the 8th root of w to the 1st. Right? That 1/8 only goes to the w. Now, if it had been 3w to the 1/8, like that, if it was in parentheses, that means that 1/8 belongs to both the pieces and both of them would go under the radical. Alright, does that make sense? So make sure we're being careful with that. This 3 does not belong, the 1/8 does not belong to the 3. So that stays outside 3 times w to the 8th root. Okay?
Okay.
Any questions? Should we try some more?
Oh, there's too many.
Wonderful. So now it's telling us change it to radical and then simplify all radicals. So make sure you're reading directions when you're doing things. So simplify them once we get there. So 9 to the 1/2 is the same as the second root of 9 to the first, or the square root of 9. 3. Right? So it equals 3. We want to simplify now, so simplify it if you can. 25 to the 1/2. That's the second root of 25 to the first. So that's going to be 5. The square root of 25. Good. 27 to the 1/3. Well, as a radical, that would be the cube root of 27 to the first. In other words, what to the third power equals 27? 3. So the cube root of 27 would be 3. Okay? 32 to the 1/5, I want to write that as a radical. It becomes the 5th root of 32 to the first. So what's the 5th root of 32? Or what to the 5th power equals 32?
Those.
2. So the 5th root of 32 is 2. Okay? Like I said, there is a button in your calculator where you can pick whatever root you want and then take that the 5th root, let's say. Hey, any questions so far? I know I'm going kind of fast, but it is a short day. Do we have any questions? Okay. 9 to the 3/2. 2 ways to do it again. We can take the square root of 9 cubed, or you can take the square root of 9 and cube it. So, sometimes doing it the opposite way, the way that I don't like to do it, really, sometimes that works better. It's a little bit easier. Right? If I do the top way, what's the square root of 9? 3 becomes 3 cubed, which is 27. That one was nice and easy, right? Or you could do, well, what's 9 cubed? Anyone do that in their calculator? 729. And then what's the square root of that? 27. You get the same exact answer either way. Right? This way you got to use your calculator a little bit more. This way you can probably do it in your head. Right? Square root of 9 we all know is 3, and then cubed is 27. So both ways work. Both ways get you to the same answer. Alright. 8 to the 2/3 power. Well, it's the cube root of 8 squared. Or it's the cube root of 8 squared. Well, 8 squared is 64. What is the cube root of 64?
Oh, that's
4, right? 4 cubed will give us 64. Well, if I try it up here, the cube root of 8 is 2, and I know 2 squared is 4. I get the same answer for both of them, right? You should get the same answer every time if you do it correctly. Maybe like what, 4 more, I think? Is that it?
Nope.
64 to the 5/6 power. Remember, our denominator becomes our radical, or our root. So 6th root of 64 to the 5th power. Or the 6th root of 64 to the 5th power. Either way should give us the same answer. Well, what's the 6th root of 64? Or what to the 6th power gives me 64? Write in your calculator if you don't know.
I got to find
You know what it is? What's the 6th root of 64?
Well, the answer's 32.
Well, I want to know what the 6th root of 64 is. 2? Thank you. So then I get 2 to the 5th, which equals 32. Does anyone know what 64 to the 5th power is? Did someone do that in their calculator?
3741.
Okay, hold on. 107.
374 1824.
Right, that's a pretty big number,
That's a big boy number.
right? So then you take a 6th root of that, you should still get 32. Now, which way do you think is easier to do? The top or the bottom?
The top.
Probably the bottom, right? So sometimes the other way that, like the way that I don't like to do it, sometimes I'll still do it that way because it is easier, it's quicker. Alright? So some of these bigger numbers, when we're using the bigger numbers, it's easier to do it the way that I said I don't like to do it. Okay? Sometimes you gotta do things you don't like.
Oh, man.
Right?
Oh, me.
Alright, 125 to the 2/3 power. So the cube root of 125 squared. Well, what's the third power is 125? What's the cube root of 125? 5. So then 5 squared is 25. Is anyone when we get out of here?
112.
In a minute.
12? Oh, we got plenty of time.
What?
We got all the time in the world.
That's 11 more minutes.
Yeah, all the time in the world.
No.
Time is relative, you know that?
No, it isn't.
Yes, it is. 121 to the negative 1/2.
111.
Cool, what's the first thing I had to do?
Make the exponent positive.
Make it positive, so put it in the denominator. 121 to the 1/2 power becomes 1 over the square root of 121, right? It's the second root, 121 to the first. 1 over 11. Alright, last one. 1/32 to the 1/5 power.
What?
What?
What are you doing, man?
What?
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 What are you doing?
So, I want to make it a radical. The 5th root of 1 over 32 to the first power. What? 0.5. Do you think I should give a decimal answer?
No.
1/2.
1/2.
Ooh, we got him good.
So, hey, here's a trick that I think we're going to learn later this unit. Is that you can take and you can do the 5th root of 1 over the 5th root of 32. So you get 1 and you get 2. We're going to learn that later in the unit, but that is a nice little trick in case you counter that in the homework. Alright? Any questions?
Ooh, I missed.
Hey, how do we feel about this? Good, so-so,
Wait,
good,
Is
so-so.
there anything above this?
Okay. Alright. We have homework.